Hey Sevens, welcome back to school. Hopefully you guys had a nice break. We're actually going to go straight into going back over stuff that we actually learned at the end of last term. Now for some of you this is actually going to be new information. For some of you, I know in my class we've actually already done this in class, so this is actually revision. So this is going to be exercise 4E and 4F on adding and subtracting fractions, and it's on page 208 or 214 of your textbook depending on what exercise you're looking at. Great. So you guys might already be familiar with this, but the idea of adding and subtracting fractions, they must have the same denominator. Now, for those of you who don't remember, a denominator is a number on the bottom. So for example, if I have a over b, the denominator is b. Now, if we're using real numbers, so for example, 2 over 3, then the 3 would be the denominator. And actually, the numerator is the number on the top. So hopefully you guys remember that. So it would be 2 in that case, and a in this case over here. Now, if I've got same denominators, all I do, and you can follow along with this, you add, oops, sorry, not that section over there. You add the numerators and keep the denominator. Okay, that's it. You add the numerators and keep the denominator. But if the denominators are different, we need to actually use a knowledge of equivalent fractions to convert them with fractions with the same lowest common denominator, right? We'll go through those steps in a second, but what I want to do is actually practice what happens if the same denominator is in those fractions, okay? So over here on the left, I've got add the following fractions, 1/5 plus 3/5. First thing I can tell was that they've got the same denominator, so I don't actually have to do anything to the denominator. I know that I just add the numerators and keep the denominator. So what I'm going to do is I'm going to write the denominator in the bottom first, because I know that's not going to change. And I know that the numerators can add together, so 1 plus 3. And that gives me 1 plus 3 is 4, so 4 over 5. Okay, should be quite straightforward. Now for this one over here, we've actually got 3 fractions, but you also notice that they all have the same denominator. So what I'm going to do is I'm going to add them all together, and then I'm going to have to simplify. So I've got 3 over 11, so they're all going to be over 11, right? So all over 11, I've got 3 plus 5 plus 6, and that gives me, well, 8 plus 6 is 14, so 14 over 11. But you'll also notice that it's an improper fraction. We don't like to have improper fractions as an answer, so we'll change it into a mixed number. To change it to a mixed number, I'm thinking, well, how many times does 11 go into 14? Only once. Well, how much would there be left? Well, 3. So it'd be 3 over 11. Awesome. Now, what happens if there are different denominators? That's the question. So let's go ahead and look at this one on the right. So 1/5 plus a half, right? So a fifth plus a half, we can tell the denominators are different. I've got 5 on the left and I've got 2 on the right. So what I can actually do is I can actually try to make them have the lowest common denominator. Okay, now I'm thinking 5 and 2, so let's start with 2. Right? What are the multiples of 2? I know there's 2, 4, 6, 8, 10, 12. Okay, what about 5? 5, 10, 15. I can actually stop there. The reason I can stop there is I can see that there's actually a lowest common denominator right there. A lowest common multiple, right? It's 10. So what I'm going to do is I'm going to think, well, 5, what number do I multiply 5 by to get to 10? Well, 5 times 2, right? And if I do it to the bottom, I have to do it to the top. So I end up with times 2 there. Now for the right hand side, I've got over 2, right? So how do I get to 10 from 2? I times by 5. And then I do the same to the top. So I actually end up with a fraction that's 1 times 2 over 5 times 2 plus 1 times 5 over 2 times 5. Okay? So from there, I can actually just simplify it. So I got 1 over 2, 1 times 2, which gives me 2, over 5 times 2 is 10, plus 1 times 5 is 5, over 2 times 5 is 10. I add them together, I get 7 over 10, that's it. Let's go ahead and apply this to a different question. If I've got this question on the right, I've got 3 over 4 plus 5 over 6, I clearly don't have the same denominators. So I need to find the lowest common denominator, I need to convert the fractions to the equivalent fractions, and then add the numerators and write it over the total above the LCD. Now that looks confusing, but it's exactly what we've done. So we're just going to do the same thing again. Okay? So I've got 3 over 4 plus 5 over 6. So what's the lowest common denominator? I've got 4. So multiples would be 4, 8, 12, 16, 20, blah, blah, blah. I've got 6. My lowest common denominators, my lowest common multiples would be, or could be, 6, 12, 18. I can stop there. The reason I can stop there is because there's 12s there. So I know the lowest common multiple is 12. So from there, I'm thinking, what do I multiply 4 by to get to 12? So 4 times 3 actually gives me 12. And if I do it to the bottom, I have to do it to the top. I end up with 3 times 3 there. Now, same thing on the right, except it's going to be a different number because 6 times what gives me 12? Well, 2. So I'm going to write 6 times 2. And if I do it to the bottom, I do it to the top. Now, what I'm going to do is I'm going to actually skip a few steps. So I'm going to write, instead of writing 3 times 3, I'm actually going to go ahead and just write 9 on the top. And on the bottom is 4 times 3. That would give me 12. Plus, now 5 times 2. Now that's just going to give me 10. And on the bottom, 6 times 2 gives me 12. So I'll add them together. I got 19 over 12. Now the issue here is that that's a improper fraction. So once again, we need to make it into a mixed fraction. How many times does 12 go into 19? Once, with a remainder of 7. So 1 and 7 over 12. So that's adding fractions. Hopefully that makes a bit of sense. We're going to go ahead and actually subtract them now. Now, when subtracting fractions, we need to make sure the first fraction component is larger than the second. Okay? The reason being is you can't actually take away a larger amount than you already have. Okay? So, but when you're in doubt, convert to improper fractions, and I'll show you what that means in a second. Let's go ahead and simplify these ones on the left. So 7 over 9, take away 2 over 9. It's actually pretty similar to adding fractions, right? So 7 over 9, well, we've got the same denominator. So I'm just going to write equals 2 over 9, because we keep the denominator, and we take away the numerator. So 7 take away 2 would give me an answer of 5 over 9. And that's it. Let's go ahead and do the second example over here. So 5 over 6 take away 1/4. Now the issue here is they've got different denominators, right? So I'm going to go ahead and do the same thing before. We know that the lowest common multiple is 12 because we did that earlier. So it's 12. So I'm thinking, well, 6 times what gives me 12? That's 2. And if I do it to the bottom, I have to do it to the top. And over here, 4 times what gives me 12? 3. So 4 times 3 and 1 times 3. I'm going to skip a couple of steps. So I'm going to say 5 times 2, which is on the top left. 5 times 2 gives me 10 over 6 times 2 is 12. Take away 1 times 3 is 3. Over 4 times 3 is 12. And that gives me, well, I should really write that, 10 take away 3 over 12, which gives me 7 over 12. Now, on the right over here, this is where it gets a little bit confusing, right? So what I'm actually going to do first, I'm going to take away the whole numbers, and then I'm going to deal with the fractions. So 5 take away 3 actually gives me 2. So now I'm going to write 2 and 2/3, because we can't ignore the fractions over here, right? So 2 and 2/3 take away 3 1/4. So not 3 1/4, just 1/4. The reason why it's not 3 1/4 is because we already took away the 3 from the 5. Okay, so I get 2 and 2/3, take away 1/4. I'm going to go ahead and convert to an improper fraction. Okay, convert to an improper fraction. To do that, I'm thinking, well, 2 times 3, so these two numbers multiplied together gives me 6, and add that to the top, so 6 plus 2 gives me 8. 8 over 3. Take away 1/4. Now, we know that the lowest common multiple is 12, and we know that from earlier. So I'm thinking, well, 3 times what gives me 12? Well, times by 4. 8 times what gives me 12? Well, sorry, that's not correct. I times the bottom by 4, so I times the top by 4. Over here, 4 times what gives me 12 is times 3. And if I times the bottom by 3, I times the top by 3. And I end up with 8 times 4 is 32. Over 3 times 4 is 12. Take away 3 times 1 is 3. Over 4 times 3 is 12. And I end up with 32 over 12, take away 3 over 12. In other words, 32 take away 3, all over 12. And that gives me 29 over 12. Now, once again, that's not a mixed number. It's an improper fraction. So I'm going to go ahead and make that into a mixed number. How many times does 12 go into 29? Well, it actually goes in twice, because that ends up being 24, right? So twice, and 24. Now there's 5 left, so I write 5 over 12. Great. Last question, last practice question. Oops. Let's bring it back. Awesome. So I've got 8 and 1/5 take away 4 and 3/4. First thing I'm going to do is I'm going to take away the whole numbers. So 8 take away 4 gives me 4 and a fifth. Now I can't forget the fraction on this side, so I take away 3/4. Okay, now I'm going to turn the left one into an improper fraction. So I'm going to say 4 times 5 is 20, plus the 1 on top gives me 21. Apologies for the bell. 21, so 21 over 5. Take away 3/4, the lowest common multiple. So I've got 5, 10, 15, 20, and with 4, I've got 4, 8, 12, 16, 20. So I know the lowest common multiple is 20. So 5 times 4, 21 times 4, and 4 times 5, 3 times 5, and I end up with 84 over 20, take away 15 over 20. Okay? Now, 84 take away 15, so 84 take away 15 all over 20, and that gives me 69 over 20. Now, once again, that's an improper fraction, so I'm going to turn to a mixed number. I think, well, how many times is 20 going to 69? Well, 3 times, because that gives me 60. And there's 9 remainders. There's 3 and 9 over 20, sorry. Hopefully that makes sense. Best of luck. Let me know if you have any questions.